Okay, this is Circuit Analysis Lab, and we're currently doing exercise number 9, which is a series parallel circuit lab. We have already hooked up our power supply and going through our amp meter, and our amp meter back to our board on the positive side of our proto board, and negative side of the proto board back to our power supply. So we're ready in that regard. So the first thing we're going to do is hook up, we're going to measure some resistance, but we've already done that, so there's no reason to. And we're going to hook up 4 resistors, a 22K, a 220 ohm, and a 330 ohm in parallel, and then a 510 and a 410 in parallel, and then we're going to be in series on the whole thing. So we're going to commence doing that. So we're coming from power through 2 resistors. And then from those 2 resistors, we'll add a wire so we know that we're in series at that point. And besides, we're going to have to yank the wire up to measure current sometime anyway, probably. And then 2 more resistors. That'll be in parallel. And with a little bit of luck, we put the right ones in the right hole. And then we're going to go back to the negative side of our proto board. Okay. Now what we're going to do is turn it on and calculate the total current. We're going to measure the total current. Okay. So we other way. So we're measuring our total current, and we currently have 20.7 milliamps. And that's because we're supposed to be at 5 volts, and we're currently at 12. So let's crank our voltage down to the 5 volts we're supposed to be at. Alright, so now we're at essentially 5 volts, and we see, and we'll change the scale once more, 8.4 milliamps. Okay, it wants us to measure the voltage at A and the voltage at B, and that's a silly notation. What it's asking us to do is measure the voltage across the first set of parallel resistance and the voltage across the second set of parallel resistors. That's what it's asking us to do. And we see the voltage across the first set is some number. Looks like 1.1 would be a good number. And then we're going to measure the voltage across the second set. And because we have 5 volts and 1.1 across the first one, the second one's going to be greater than 2, and we have 4. So we have 4 volts across the second set of maybe. So there's something funny going on with our one resistor. We're not sure what it is, but it can't be that funny.
Well, Jacob, we don't have any.
Fixed it.
Okay, so there we go. Now we're getting the voltage right. That's fine. And because that second resistor appears to have been in slightly wrong, our current is now measuring 13.4 milliamps. So we're going to go with the 13.4 milliamps. And we'll remeasure the voltage. So voltage across A, we have 1.7 volts, 1.75, okay? And we have 3.25, and we add those together and we get that it adds up to the right amount. And those values will go in table 9, where we also have to calculate those values as well. And we're not going to go and show you what's in the lab book because it is, we don't want you to look at it. Okay, so that's good. The next thing we're going to do, construct the circuit in 9.1. Okay, we're not going to do that. We're going to refer to the circuit in 9.2 and calculate the equivalent resistances that are in 9.2. So those are calculations, that's fine. The next thing we're going to do is we're going to construct that 9.2 and we're going to measure the various resistances and voltages. So we will now construct what's in figure 9.2. And we may or may not be missing a resistor. A 1K one?
That's a 330.
You're missing the 230?
The 330.
The 330.
I got it.
You got it? Okay, so we have a coming from our power, we go I think we missed by one.
Yeah.
We missed by one. Okay. And now it looks like our circuit is drawn okay. Okay, so we got the circuit right. And the first thing we wanted to do is measure the total current. And because of the way our current meter is hooked up, that's our total current, 8.13 milliamps. Now we're going to want to measure the current through the A branch and the current through the B branch. So what we're going to do is we're going to pull one side of our 220 ohm resistor, and when we, no, just leave it hanging there. And that's going to be the current. No, we can't do that, can we?
We gotta take apart on it.
Yeah, we can. Yeah, we can. We can pull that and find the current going through the A branch. And so now we have 3.88 milliamps. All right, now we want to find the power through the B branch. So we'll put that resistor back in. And we'll pull these guys out of the circuit. And our current meter says 4.35. And if we add that 4.35 to the 3 point something we got from the other side, we see that that's the same as the total current. Okay, so now we're going to want to measure voltages. Voltage across R1. And R1 is a 1K resistor right there. So we're going to measure voltage across R1. And I'll get on the meter and I see don't see anything yet. Oh, there we go, 3.8 volts. And then the voltage across R2, which is a 330 ohm resistor, 1.27 volts. We'd expect the voltage across the bigger resistor to be higher, and it is, that's good. Then we're going to measure the voltage across R3, which is the 220 ohm guy on the top. And we see 0.93 volts. Okay, and then we're going to measure the voltage across R4, which is a 470 ohm resistor, 2 volts. And then we're going to measure across the 510 ohm resistor, and we get 2.14 volts. Now there's calculations to do and variances to find out to see what the difference is. And with that, we are done with lab 10. Actually it's lab 9, experiment 9, with the exception of answering questions and doing a simulation in Multisim.